Welcome everyone to another Kuta worksheet tutorial. We're going to be adding and subtracting rational expressions. This is a pretty difficult concept for a lot of people. Most students don't like finding common denominators and fractions in general, so when you get a rational expression involved, it just becomes a little bit more complicated. But I'm going to break this down into two videos, step-by-step process, hopefully simplify it a little bit for you. So when we're dealing with adding and subtracting rational expressions, the first step we always need to make sure we take care of is finding a common denominator. This is absolutely the number one prerequisite before you get down to the nitty-gritty. Finding a common denominator. Okay, this step 2 and 3 and 4 we can do later, but we're going to first identify that with our first problem. So here we see that the denominator is both 8v. For both the fractions involved, both the rational expressions. So now we can proceed to step 2. Distribute any negative signs if necessary. Not necessary here because we don't have subtraction in between the two. This is a plus, so that makes it easier for us. And then we're just going to add and subtract the numerators. So the real kind of simplified process for this just becomes in that we're going to keep the denominator the same, and now we are going to add the numerators. So we're going to add 6u and u, and then u minus v, and then 6u minus 3v. So let me go ahead and write that in green. So we have u minus v plus, let me change this to this color, plus 6u, I should put a little tail on it, 6u minus 3v. Okay, so we're going to look for like denominators here. In this case, we have u and 6u as like terms, not denominators. And then we have negative v and a negative 3v. We're going to keep the denominator the same. We already have 8v. We are good to go there. He doesn't need to change. So we're going to leave 8v. There's nothing more we can do with simplifying the denominator. So we're going to leave it as 8v. Now in the numerator, we're going to change 6u plus the other u, so that gives us 7u. We're going to keep, well, we need to find out here. We have a negative 3v minus v, that gives us a negative 4v. And now we're going to see if we can simplify. How do we simplify? Well, if all the terms have a common factor, we could divide by the common factor. 4 and 8 have a common factor, but because 7 doesn't have that same factor, which is 4, we can't simplify it. So this is going to become our simplified expression. So 7u minus 4v over 8v is our simplified fraction, our simplified rational expression. Okay, let's go on to number 2 real quick. Again, we already have a common denominator, so we're good there. That's a great start. And now we're going to move on to step 2, distribute any negative signs if necessary. This is where it becomes a little bit more complicated if you have the negative sign right there, because it's going to affect anything after it. How does that look? Well, let me go ahead and get this set up. We're going to have 6m cubed n. Denominator stays the same when you're adding or subtracting rational expressions. That's why it's called a common denominator. It stays the same. And now we have m minus 3n. That's going to stay the same. m minus 3n. There's no negative in front of that rational expression. And now we have to distribute this negative sign to both these. Think of it as a negative with an m plus 3n in parentheses. So that's become minus n as we distribute that, and then a minus 3n. It's just going to be the opposite sign. So if there's a negative 3n in the parentheses, it would become a positive 3n because we distribute the negative sign. But in this case, they're both positive in the parentheses, so they're both going to become negative after the distribution. Now we're looking for like terms here. We have an m and a negative m, and then we have, what else do we have? Green. We have a negative 3n and a negative 3n. So this one's going to be rather simple. We are going to have, again, 6m cubed to the n, or sorry, not to the n, 6m cubed times n. And then in the pink, we have an m minus the m, and that cancels out. They negate each other, so we have m minus m is 0. We don't have to write the 0 though, but technically we would write 0 plus if we wanted to. And then we have negative 3n and negative 3n. That gives us a negative 6n. So the way we should write this is negative 6n over, divided by, however you want to say it, m cubed to the n. Now, we can get into this last part, so we added subtracting numerators. Now we're going to factor and reduce. So in this one, we couldn't factor anything out. We couldn't reduce. But look at this one. Here we have a 6 and a 6 that we can cancel away. And then we have an n and an n that we can cancel away. Don't make the mistake of putting 0 in the top. That's not a 0. When it cancels, it's reduced to 1. It's technically 6 divided by 6 equals 1. So we're going to have negative 1 in the top, nothing else there because it all canceled away, over m cubed, and that's our final answer right there. Okay, so we got the basics of it when we have a common denominator. Common denominator is not too bad. And the trouble often becomes factoring and reducing. So let me do a quick example of that, and then I'll show you how to find common denominators. So let's say we're doing this problem right here. It looks complicated. It's not too bad. We're going to keep the denominator the same. I'm going to do all the same color now that you understand it. We have a squared plus 3a plus 2. We don't have to worry about this negative sign, so we're just going to add the terms. So we have a 5 and a 1 that we're adding. We're going to get 6. And then we have a positive 5a that we're going to add there. Now, it looks like we're done, but again, our objective is to factor and reduce in this stage. So what we're going to do here, we are going to factor this further. So 6 plus 5a cannot be factored any further. But a squared plus 3a plus 2 can. So we're going to put it into two parentheses because it's a trinomial, and we have a plus, what is that, a plus 2, a plus 1. So it looks here that it doesn't do us any good to factor further because there's nothing more to cancel. But let's say if there was an a plus 1 in the top, we could cancel that, and then we'd just be left with whatever is in the top over a plus 2 if it got canceled away. So that's something to keep in mind. Now let's jump to a problem like number 7. Now, to do a problem like number 7, I'm going to introduce the concept of finding a common denominator with denominators that look like that. So let's start with the basics of common denominators. So as we've learned before, common denominators, if we have 1 over 4 plus 2 over 5, a way we can always find common denominators is just multiplying the two bases by each other. So if we're trying to change 1/4 and to have a common denominator with 2 over 5, we could just multiply the 4 times the 5. 4 times 5 would give us 20. 20 is a common denominator between 4 and 5. 4 and 5 are now factors of 20. But what we do at the bottom, we also have to do at the top. Likewise, how do we change 2 over 5 to be a common denominator with 1 over 4? We just multiply it by the 4. We can multiply the denominators times each other to find a new common denominator. In this case, we'd get, kind of ran out of room, but just I wasn't intending to do this. We'd get 5 over 20 plus 8 over 20, and then so our final answer would be 13 over 20. Whoops, not 12. Over 20 for our final answer. Okay, so that's how you simply find a quick common denominator. The same can also be applied of expressions. So let's say we have 1 over a plus 2 over b plus 2. A little bit more complicated now, but the principle remains the same. If we're trying to find a common denominator, we just need to multiply the two denominators together. So in this first ratio, 1 over a, if we're trying to find a common denominator, just multiply the base by b plus 2. But what you do to the bottom, you also have to do the top. So we're just multiplying the denominators together, but you also have to multiply the top by whatever you multiply the bottom. Same thing with the other fraction, the other ratio. We had 2 over b plus 2. We want to multiply the bases together, so b plus 2 times a. We're missing that a, so we have to multiply the base by a, but what we do to the bottom, we also have to do the top. And that's how we find a common denominator. So let's go ahead and simplify this one step further. Here, we would have b plus 2 in the top on the left side over a times b plus 2. That's our common denominator. And actually, I can extend it because that's our common denominator, like I said. Let me highlight this. And then we have here plus 2a. So technically the top is about as simplified as it can be. I could rearrange the letters a little bit. So 2a plus b plus 2 over a times b plus 2. And that would be my final answer. You could factor or reduce if possible. In this case, it's really not. So we're done. But the main principle is we can multiply the bases together to find a common denominator. Let's go back to 7. So if we're looking here at 7, we recognize here, let me change this to a different color that you can recognize. If we have x minus 1 here, and we have 4 here, then what we can do is we can multiply this guy by 4, and this guy by x minus 1, and we can find a common denominator that way. Now, we have to also multiply the top by x minus 1 here. We also have to multiply the top by 4 to keep the fraction balanced without changing the value. So now we have 24 over 4 times x minus 1, that's our common denominator, minus 5x times x minus 1 over 4 times x minus 1. As you can see here, we have our common denominator, 4 times x minus 1. So that's going to be our new common denominator for x minus 1. I've simplified the bottom. Now I just need to worry about the top. So it becomes 24, let me get changed to green. 24 minus 5x times x minus 1. Okay, it might be tempting to cross out the x minus 1, but you can't because there's addition in the numerator, so you can't just cancel them out. We might be able to factor if possible, but I'm guessing the best way to clean this up, so to speak, is to actually multiply the top and bottom. That'll make it look a little bit better. So we're going to distribute this here, and we're going to distribute this here. In the bottom, we would get 4x minus 4. In the top, you would get 24 minus 5x squared plus 5. Because remember, we had that minus there, so it sticks with the 5x. And then negative 5x times negative 1 is positive 5. So now we can simplify that one step further. We get, I'm going to leave the negative 5x squared first, and then we have plus 29 because these two guys are like terms. And then we divide by our denominator, common denominator, 4x minus 4. Let's do one more, just because there's a little bit more complicated ones. We'll do number 12. So we have 5 over n plus 5 plus 4n over 2n plus 6. As you might have guessed or figured out, what we need to do is we need to put this 2n plus 6 there. And then we also need to have an n plus 5 over here. Now what you what you multiply by the bottom, you also have to multiply to the top. So I need to have this 2n plus 6 multiplied to the top, and this n plus 5 multiplied by the top on that side. It's advisable to first do the distribution. So let's distribute here. So we get 10n plus 30 over, and then we have a multiplication of binomials. So we'd get 2n squared plus 10n plus 6n plus 30 for this guy on the left. Okay, so that's my left one. And then my right one, let's use a different color, purple. I'm going to distribute plus, it's plus, we don't have to worry about distributing the minus, 4n squared plus 20n over, and then we have the same denominator, 2n squared plus 10n plus 6n plus 30. Okay, now I can simplify the denominator a little bit. Let me go ahead and do that step. So we have 2n squared plus 16n plus 30. Okay, and then the numerator, let's try to simplify this. And I'll use orange for the numerator this time. So I have 10n plus 20n. Since it's all adding together, I can just multiply or add the like terms. So I have 30n there. I have 4n squared by himself. So I'm going to put 4n squared out in front plus. And then this 30 is also by himself. So I'm going to do plus 30. Now you may think that I'm done here, but I realize that I have common terms between these. So I might be able to factor a little bit further and simplify this even more. So I recognize here that I can factor out a 2 in the numerator for the top. So I get 2 and then n squared, 2n squared, sorry. So I factor out a 2 in the top, and I get 2n squared plus 15n plus 15. And then I can factor out a 2 in the bottom as well. So 2 and then n squared plus 8n plus 15. And then what you also see is that you can cross out these 2's. And then it looks like our final answer is going to be 2n squared plus 15n plus 15 over n squared plus 8n plus 15. Now a quick check to see if we can factor the bottom even further. And I think we can, just to double check to see if we can't factor even further. I'm going to do the top first, actually, 2n, and then what could I get? I'm looking for factors of 15, so maybe that'd be 3, and then n, and then plus 5. That would give us, nope, wouldn't work there. What if we change this? 5, 3, 6. Nope, that doesn't work. I don't think we can factor the top any further, which is actually good, and I think we have our simplified answer right here. So that's good news there. Now we're going to go to part 2. Sorry, this was a little bit longer. Like I said, this is a difficult concept. Hope you enjoyed this stage of the video. We're going to go over page 2 after this, so be sure to join me. We're going to do some of these tougher ones, which is going to be more of these common denominators. Even looks like some complex fractions in there, so stay tuned.